On page 7, we're going to look at the next type of trigonometric equation. We will be solving an equation with more than one trigonometric function. So, if a trigonometric equation contains more than one trigonometric function, you need to apply one of these techniques. Either use a known identity to make a trigonometric substitution, or square both sides of the equation. If you go this route where you are squaring both sides, what can happen is the process of squaring both sides may introduce something called an extraneous solution. So it will look like a solution, but it's actually not. So if you go the route of squaring both sides, you need to make sure to check your solutions, because if you end up with something that's actually not a solution, you have to throw it out or exclude it. Okay, so we'll talk more about that when we get to that example. Okay, in example 7, we have the equation secant squared of theta is equal to 2 times the tangent of theta plus 4. Okay, and the directions here say to solve the equation over the interval 0 degrees to 360 degrees, and then also write down all solutions. Okay, so here we have theta. So we are in degrees, okay? This is an example, okay? I know we have something squared here, so you're probably thinking quadratic, but we have more than one type of trig function, okay? We have a secant and a tangent. All the quadratic stuff we have worked had the same trig function, okay? So although you see something squared, we first have to handle the issue that we have multiple trig functions, both a secant and a tangent. Everything we've done so far, with the exception of one problem, has had one trig function. Okay? All right, so we're going to follow the advice above. Okay? This one, I'm going to use a known identity to make a trigonometric substitution. Okay? Why am I going to do that? Okay? Well, look at what we have. Okay, on the left side we have secant squared, okay, and on the right side we have a tangent. Okay, it would be great if everything in the equation was secant or tangent. Okay, so my goal is to make everything secant or to make everything tangent, but I have to use a known identity that can make that happen. Okay, so can you think of an identity that we already know that relates secant and tangent? Okay, and yes, it's one of the Pythagorean identities. Okay, we know that tangent squared of theta plus 1 is equal to secant squared of theta. That is one of the known identities. Okay, so what we can do here is make a trigonometric substitution. I know that secant squared of theta is the same thing as tangent squared of theta plus 1. So I'm going to replace secant squared of theta on the left with tangent squared of theta plus 1. Okay, these quantities, secant squared of theta and tangent squared theta plus 1, they are equivalent. Okay, so I can substitute one for the other. Okay, I'm not going to change anything on the right side. And now if you look at what we have an equation that just has one trig function. Everything is tangent. Okay, so that is great. Okay, at this point, since we've converted over to one trig function, now we can ask ourselves, what type of trig equation is this? Okay, so when I look at this, I have tangent. Here the tangent is squared, here the tangent is raised to the first power, so I've got something quadratic. The highest power of tangent is the second power, okay? So I need to put everything on one side. One side has to be 0, and then I can either factor or use the quadratic formula, okay? So I'm going to go ahead and move everything over so that the tangent squared stays positive. So I'm going to subtract 2 tangent theta from both sides. And I'm also going to subtract 4 from both sides. Okay, I'm going to get that tangent squared theta minus 2 tangent theta, and then plus 1 minus 4 will give me minus 3. That's got to equal 0. Okay, so going forward, we're going to work with this particular equation. All right, so my options for something quadratic, I can either factor, use the quadratic formula, or this one's not a good candidate for extracting square roots because it's not something squared equal to a number. Okay, so we either have to factor or use the quadratic formula. So when I look at this, the numbers don't look too crazy, so I'm going to attempt to factor it. But of course, you can use the quadratic formula here with A being 1, B being -2, and C being -3, and you should get the same answer. Okay, so let me try to factor this. Tangent squared of theta is going to break down into tangent of theta times tangent of theta, and then I need two numbers that multiply to be -3 but add up to -2, so you might have to play around with it, but I think it's going to be this. Okay, and we can check ourselves. This is going to be tangent squared theta minus 3 tangent theta plus tangent theta minus 3. Okay, so those middle terms do combine to be the -2 tangent theta, so this is correct. Okay, so this one does factor. Okay, remember, if something doesn't factor, you need to try the quadratic formula. The quadratic formula always works, but not everything factors. Okay, all right, so we factor the non-zero side, so now we need to take each factor, set it equal to 0, and solve. So the first equation we're going to get is that the tangent of theta plus 1 is equal to 0. And then the other guy we need to solve is the tangent of theta minus 3 is equal to 0. All right, let's start with this first equation. So now we have something linear. Okay, we've got a single trig function. It's raised to the first power, so we need to isolate the trig term. So I'm going to subtract 1 from both sides. This tells me tangent of theta is equal to -1. And so what I can do is go to my unit circle and look for angles between 0 and 360 degrees. Okay, one revolution around the unit circle. Okay, whose tangent is -1. Okay, so let's go to the unit circle. We are first trying to solve the equation that the tangent of theta is equal to -1. We know that tangent is the y-coordinate over the x-coordinate. Okay, so we want a tangent of -1. Okay, we know that tangent is negative in quadrants 2 and 4, so that's where we should be looking. All right, so remember, what is going to produce a tangent of -1? Well, if your y value is equal to your x value, but they have opposite signs. Okay, so like right here. Okay, if you take the y coordinate and divide by the x coordinate, you're going to get -1. And so 135 degrees is going to work. Okay, and then in the fourth quadrant, 315 degrees is going to work. Okay, because again, if you take the y coordinate and divide by the x coordinate, you're going to get -1. Okay, so my two answers here, okay, theta can be 135 degrees and it can be 315 degrees. Okay, so let me go and jot that down. Okay, so we get theta can be 135 degrees or it can be 315 degrees. Okay, these are two solutions between 0 degrees and 360 degrees. So I can go ahead and write them down. Okay. All right. Now I've got to deal with the second equation here. Okay. So I need to, again, this is linear. This tangent theta minus 3 is equal to 0. It's linear. So I just need to isolate the tangent of theta. So I'm going to add 3 to both sides. This is going to tell me that tangent of theta is equal to 3. Okay. If I go to the unit circle, I need to find an angle whose tangent is 3, meaning if I take the y value and divide by the x value, I'm going to get 3. Okay, so let me jot that down here. So the second thing we're trying to solve is tangent of theta is equal to +3. Okay, and we need to look at our y divided by x. And again, we need to focus here. This is a positive tangent value. Okay, so we need to be focused on tangent is positive in Q1 and Q3. So that's where we need to look. Okay, if you look at these values and you do y divided by x, none of these guys are going to give you +3. Okay, so what does that mean? Okay, that doesn't mean there's no solution. It just means the angle is not emphasized on the unit circle. Okay, so we're going to say theta here is not emphasized on the unit circle. It's not one of these called out angles. Okay, so we're going to have to go to the calculator. Okay, so here what we need to do, okay, we want theta, it's trapped by the tangent. So to undo that, we're going to have to take the tangent inverse of both sides. Okay, so the tangent inverse of the tangent of theta has to equal the tangent inverse of 3. On the left, the tangent inverse and the tangent will cancel, leaving you with theta. So we need to go to the calculator and do the tangent inverse of 3. Okay, we are expecting answers in degrees, so I need to make sure I'm in degree mode. So let me go to the calculator here. I'm in degree mode. First thing I need to check, and then I can punch in tangent inverse of 3. Okay, and so we're going to get this answer. This is a degree measure. I'm going to write out the full decimal expansion for your notes. Okay, so theta is going to be 71.5650518. Okay, that's in degrees. Put your degree symbol. And so I will go ahead and round this, okay, to 4 places after the decimal point. Okay, let's see here. We've got 71.5651 if we do that kind of rounding. Okay, so 71.5651 degrees. Okay, so here we go. We've got this, one of these decimal answers again. Okay, so the calculator is only going to pop out a single answer. We have to draw a sketch of the unit circle to see if there's another answer that will work. Okay, so here I go. I'm going to draw my x-axis. I'm going to draw my y-axis. And then I'm going to put a circle on here. Okay, so here we go. Okay, we just got an angle that works, the 71.5651 degrees. Luckily, it's already in degrees, so we don't have to convert it. Okay, if I draw that out in standard position, here is the initial side. We're going to rotate clockwise 71 degrees. I'm just going to estimate it to be about right here. Okay, so this is 71.5651 degrees, we'll say. Okay, so we rotate it this way. Okay, so here's the point we would be interested in. Okay, we know that this angle has a tangent of 3 degrees. Okay, so if I call this theta, we know the tangent of theta is equal to 3. Okay, is there some other angle that is going to produce the same tangent value? Well, there's going to be. Okay, this is a positive tangent value. Okay, tangent is positive in quadrants 1 and quadrants 3. So there's some angle in quadrant 3 that is going to work. Okay, so I'm going to put it in a different color here. I'll put it in gray. Okay, so how are we going to find this guy? Okay, if we just draw it, if we're right here, okay, we need to go straight across the unit circle. Okay, like form a straight line here. Okay, that's what's going to get us there. Okay, and it's going to look something like this. Okay, so it's going to be this angle. Okay, because it's basically the same XY pair, but the signs have been flipped. Like if this is XY, okay, well, okay, so if this is XY, this is going to be negative X, negative Y. Okay, so that's why it's basically this point right here. Okay, so when you look at this, okay, you have a negative divided by a negative, it's going to give you a positive tangent. Okay, so that's just reinforcing that this is in quadrant number 3. Okay, so the big question is, how do we come up with this value? Okay, because we're talking about this particular angle. If we're in standard position, we would start along the positive x-axis, rotate counterclockwise until we got right here. Okay, so this is going to be the second angle that works. I'm going to call that theta 2. I'll go ahead and relabel this guy theta 1. okay? So, like I said, all you have to do to get this angle, okay, because you want it to have the same coordinates, but you want to flip the signs, you're just going straight across the unit circle by 180 degrees. Okay, so all we have to do is take our 71.5651 degrees and add 180 to it. Okay, so to get theta 2, okay, we're going to take this guy and we're going to add 180 degrees, okay, and that will give us a second angle, okay. So let's see here, if we go to the calculator, I'm just going to add 180 to this, okay, so that's going to give me 251 degrees, okay, and just for my little sketch, that seems about right, okay. So here's our other angle. If we go ahead and round this to 4 places after the decimal point, this is going to be 251.5651 degrees, okay. So I'm going to go ahead and add that. This is between 0 and 360 degrees, so I'm going to add that to the list here, okay. Now, the great thing is you can check yourself, okay. You know, this was kind of a strange thing to solve for, okay, but I can check myself. Does this work? If I plug it back into the original equation, am I going to get a true statement? Okay, so we can pop it in. I do want to check myself because, again, doing these decimal answers, it's weird, okay, so I do advise you to check yourself, okay. If we did this, I'm going to store this answer, okay, right here. Okay, I'm going to store it in A, and then I just need to call up A every time I'm referring to it. Okay, so I'm going to do secant squared. So this is going to be 1 over the cosine of that angle. Okay, get that result and square it. Okay, so we're going to get 10. Okay, if we pop in the 251 degrees, that full decimal expansion, you need it to check. Pop it into the right side and see if you get 10 is the answer. Okay, so we're going to do 2 times the tangent of our angle, 251 point something, okay, and then we're going to add 4, and we get 10. Okay, so we are correct. We have plugged in this strange answer, the strange angle, into the original equation, and we got the same thing on both sides, so we know we are correct. All right, so in conclusion, this original equation, secant squared theta is equal to 2 times the tangent of theta plus 4. There are 4 angles between 0 degrees and 360 degrees that make this equation true. Okay, now how are we going to have to write down the all solutions part? Okay, well, remember what you need to do. You need to take each of the angles between one period, each of the answers within one period of your trig function, and add integer multiples of the period. Okay, so remember the 135 and 315 were found together, and then the 2 decimal answers were found together. Okay, so if you go back to the unit circle, okay, 135 degrees and 315 degrees, they're pi units apart on the unit circle, or 180 degrees apart on the unit circle. 135 plus 180 is going to give you 315 degrees. So they are separated by 180 degrees. Okay, so basically you can just start with the 135. Okay, if you add 180 degrees, you're going to get 315. And then if you add 180 again, you're going to get something coterminal with 135. And then the cycle repeats itself. Okay, so you just need to take 135 degrees and add integer multiples of the period. The period of tangent is 180 degrees anyway. Okay, so we know that we are right. Okay, if you plug in n equals 1, you're going to get the 315. Okay, but if you adjust your n value to something else, it will give you an additional solution. Okay, so that's how we write all solutions based on the first 2 angles. Now we've got to deal with the decimal angles. Okay, they too are separated by 180 degrees. Okay, you just look at the sketch here. Okay, we talked about it. To get the second angle, we took the 71.5651 5, 6, and so on degree angle and added 180 degrees. So they too are separated by 180 degrees. So all you need to do is take the first angle, okay, and I'm just rounding. Remember, this is rounded to 4 decimal places. Put your degree symbol because it's in degrees. You're going to add integer multiples of the period. The period of tangent is 180 degrees, okay? You plug in n equals 1. It's going to generate this 251 degree number, okay? And then you can pop in any n value to generate additional solutions.